example problem 816, which is from section 2 of chapter 8. The topic is confidence interval estimate for the mean, where sigma is unknown. Okay, so we're trying to estimate what we think the value of the mean is, and we don't know the population standard deviation. So this problem is from page 261. It's problem 816. It says, a survey of nonprofit organizations showed that online fundraising has increased in the past year. Increased is a key word. That means it's greater now than it used to be before. Okay, based on a random sample of 55 nonprofits, the mean one-time gift donation in the past year was $75 with a standard deviation of 9. Notice the standard deviation came from the random sample of 55 nonprofits. It's not a population figure that was given to us. So that's how we know that we need to use T instead of Z. Part A says, construct a 95% confidence interval estimate for the population mean one-time gift donation, and then interpret the interval that you construct in A. So this is what we know in the problem. X bar equals 75, N equals 55, S equals 9. The critical value of T we'll find from our table is 2.0049, and I'll show you in another slide or so where that number comes from. The degrees of freedom are going to be N minus 1, because I have one sample, and the sample size is 55, so therefore the degrees of freedom are 54. Alpha is 0.05, because we want a 95% confidence interval. That's the information we're given. Why are we using the formula we are? We want to estimate the mean. Doesn't tell us what the mean is. We're supposed to come up with that. Sigma is unknown because the value for the standard deviation was only from the sample. We're assuming a random sample and a normal distribution. And we're assuming that, and let's look back and see for sure, our population size is 55, so it's likely that this sample is normally distributed. So we don't have to worry about whether the population is or not, because the sample size is greater than 30. We want to use a confidence interval for the mean using a t-test. So we want an estimate within a range of the mean, and we don't know the standard deviation for the population, so that's why we're using t. Here's where we get the critical value. We look at the t table, which is table E3, and we look in the upper tail area column, which is 0.025, because it's 0.05, and confidence intervals are always two-tailed. So I divide by 2, gives me 0.025 in each tail, and 54 is the degrees of freedom because n equals 55. So the value from the table is 2.0049, which is the value that we wrote down over here on the previous slide. Okay, then we plug into our formula, x bar plus or minus t alpha divided by 2 times s over the square root of n. So s is going to be my sample standard deviation, n is my sample size, t is the value I found in the table, and 75 is my x bar. So this is x bar, this is t, this is s, and this is 55 is n. So if we look back, the numbers we were given, that's where those numbers are coming from. Okay, so then what I do is I calculate this part. I do the square root first, then divide by 9, multiply by 2.0049, and I come up with 2.4331, which I add and subtract from 75. So my interval for mu is going to be somewhere between 72.5669 and 77.4331. That's part A. Part B said, looking back there, interpret the interval constructed in A, and it says we are 95% confident, because that's the interval we constructed, that the population mean is somewhere between $72.57 and $77.43. We thought that maybe the value is now greater than it used to be. If we go back here, it says, so what do we think the actual value is? We think it's increased in the past year. Survey showed online fundraising has increased. But when we look at the numbers, we say, well, It's somewhere between 72.57 or $72.57 and $77.43. Since 75 is not above the lower limit of the interval, we cannot say that the mean level of one-time gifts has increased. It may be the same, it may be somewhere in this range probably with 95% confidence, but it may be no greater than it was before.